So now in this video we come back to the astable multi-vibrator circuit I built with an NE555 timer, and it's astable mode. So this capacitor is charging to 2/3 voltage and discharging to 1/3 voltage back and forth, and each time it reaches one milestone or the other, the output changes, and an LED, either the red one or the green one, lights up because they're going to opposite rails. So I have this analog meter. I bought it really only for this purpose. I bought it a long time ago, but in any case, it has a needle that moves instead of numbers that show up on the display. So first we will connect to the resistor. It's a little tricky to get a good connection though. One of the resistors coming out of the output there. But there you can see that the needle is moving between 0 volts and 4 volts. So that's what the output is doing. The output is changing from 0 volts, the same voltage as the negative rail, to 4 volts, which is a little bit shy of the positive rail right there. So it doesn't go all the way to the positive rail. Looks like it goes to about 4 volts. And this is 6 over here. 4 there, 6 there, and then 2 there. So now, as we could see, and I don't know what I did wrong there, as we can see, the output, it rapidly jumps, the needle rapidly jumps when one of the LEDs changes. So they actually change instantly. It goes instantly from, it looks like 4 volts here to 0 volts. And so the analog meter isn't too exciting in that aspect. Where it's better than a digital multimeter. Okay, I see what's wrong. The power supply is a little loose. There we go. So it's probably time to swap it out. I bought a bunch of these power supplies, and I got a bunch in reserve. But in any case, now we have the voltage of the capacitor, and we can move this over here. Doesn't matter either way. But now you can see it's going to about 1/3 of the power supply voltage. The red LED turns on, so that lets us know the output is high, because that's how I wired it. And then once it goes up to about 3.3 volts, in that range, somewhere around there, then you see the output changes and the voltage of the capacitor starts going back down. So pin 6 and pin 2 are alternating whether the output is high or low, and whether the capacitor is charging or discharging. So you can see that when the output is high, the capacitor is charging, and it takes time. And so these are 1 kilo ohm resistors, and when I had a 47 microfarad capacitor and 10 kilo ohm resistors, the meter would not let the capacitor charge. It was taking too much current, so I had to use lower value components. But in any case, you can see it's kind of nice to see that needle move while a voltage is changed. And a better meter would look even better. So I'm going to turn this off. I don't think it used any of the battery at the voltage setting, but probably better to turn it off anyways. So now let's get the digital multimeter that I use a lot, and good, that fit on there pretty nicely. So I'm going to set the meter to measure voltage. It's an auto ranging meter, and so if it wasn't auto ranging, if we set a dial to a range or below, it would probably do a little bit better, I think. But in any case, we'll go to this jumper, which goes to the negative rail, and go to the output, and there you can see it's jumping. It looks like between 0 and 3.6 volts. So it's bouncing back and forth. So this is doing probably about as good as the analog meter for showing that. But then we come over to the capacitor, and you can kind of see it sliding back and forth between those voltages, but it's a lot more distracting to have a bunch of numbers flipping around. So that's one reason why somebody might still hold on to an analog meter and use it. If you have a sliding voltage, it's a lot easier to read a needle that is sliding than a digital. But for really rapid changes, it still takes time for that needle to go. If you have a good multimeter, it will jump between those two numbers and might be a little more clear. But in any case, that's really the only reason why I bought that meter, and they're not really used anymore. But if you have a sliding voltage that you want to keep track of, it may be nice to watch that needle move instead of numbers. So thanks for watching. I will see you in the next video.